Appreciate it. Can you see my screen, Chris, and the sound okay?
Yeah, all good.
Beautiful. Appreciate that. First and foremost, super excited to be here as always. Chris and Lee and the NFCA, we go back a few years back, so always enjoyed the collaboration, always enjoyed the speaking opportunities, always enjoyed crossing paths. So thank you for what you've been doing over the past couple of months on these webinars. I'm sure it's quite helpful for everyone attending. And of course, thank you for those of you that are signing up to the call. I hope that the next, let's call it 45 minutes or so, is going to be beneficial for you. As Chris mentioned, this is a part one or two. I am going to go a little bit more into the generic things this session. So obviously, if there are questions at the end or even following the call, I'll be more than happy with my team to answer any questions you may have. But ultimately, I try to pack as much content as possible within the time that we have. So thanks again for being here and excited. Very quickly, who Acoustics is. Ultimately, what you need to remember is we're a Quebec-based company. I personally live in Calgary, adopted Albertan, been doing this for basically 20 years now. Great team, passionate team, experts, so we love what we do. And ultimately, with the help of, obviously, we got Suprema firm ourselves. So make a long story short, what we do on a day in, day out basis is we guide you, bring solutions to people that are frustrated with possibility of acoustic complaints or lawsuits, customer negative perception of their buildings. There's a lot of that. We're experiencing a lot of that all throughout the country. New code regulations, example, it's not always about acoustics or how is the code affecting my design. What can we do? What are our options? A lot of people sometimes have a hard time navigating through this. There's obviously misguided information, which we'll talk about a little bit later. And even like, for example, weight. So weight, budget, acoustics, so everything is taken into consideration when we tag along or have a conversation with you. Last but not least, which is certainly related to the flooring industry, would be abundance of products and unclear information. Chris and the NFCA have been advocating for this for years, that ultimately we're trying one call at a time, one webinar at a time to change how people are seeing acoustics and what should be done, at beginning of the process, during and after. So that's what we're going to be focusing on. So that's what ultimately Acoustics is about. And there is a lot of frustration right now, and technically it shouldn't be the case. Very quickly to set the table, here's some fun facts and data, just put things in perspective. 65% of multifamily residents have experienced some kind of a noisy neighbor. That's a lot. Obviously, there's tons of multifamily, whether it's rental or condo owned or even hotels, but 65% are experiencing acoustic issues or complaints. So that's a very high ratio. And once again, that ratio should drop down. We need to kind of, make sure that we dropping it down. Number one cause of avoidable resident conflict, resident generated noise disturbances. So again, it goes to show to some extent the importance of this topic. But not only that, is it's become way worse over the past couple of years for obvious reasons. Remote working in Canada went from 4% in 16 to 32 in 21. We don't suspect this will go down. It's only going to go up, even though things are starting to reopen up. Doesn't change the fact that people got acquainted with working from home. To be efficient is still to some extent a challenge, but people are finding new ways to be more efficient from home, which means people are spending more time into their multifamily or condos or apartments, which obviously could be a little bit challenging on that front. New York City noise complaints rose by 42% after first months of confinement in 2020. So you understand that 2 years later, that number is definitely not lower. It's most likely higher. Waking time spent at home went from 50% in 19 to 62 in 20 in the US. So that speaks for itself. Hybrid workplaces to become the norm. Only 17% of businesses say back to the office as soon as feasible. So again, there's a trend of working from home. More people are going to be spending it at home, which means it's directly linked to the number of complaints we might experience. The agenda, what are we going to focus on to some extent? So we'll go to the core of our conversation to some extent. Introduction, obviously kind of did it. STC, IIC ratings and measurement and how that works. We're not going to become acoustic engineers by any stretch, nor is this webinar designed to make us experts in the field, but at least we're going to talk about the basics and the generic information that comes with that. Building code requirements and recommendations. There will be a combination of what the law says and then what we see. So I'll allow myself to share a few things that we've been seeing for the past 20 years. We're going to talk about acoustic principles. Why are we going to do that? Acoustic principles should dictate flags or things that you're looking at on a daily basis. So when you're working on a design, you live in an existing building, understanding the principles, and that's ultimately what we want. If you understand the principles a little bit better than you did before, it allows you to I guess do an analysis of your current situation and see possibly where problems could be coming, like where they're coming from. So that's what we're going to take a few minutes to talk about the principles. Not a lot of people talk about structure types. People assume they're all the same or they all do the same. So I want to talk about the structure a little bit in depth and put things in perspective. Last section, which is a little bit quicker to some extent, is just pick your brain, put some ideas in front of you on floor ceiling assemblies and what they could look like depending on the structures. And of course, take a couple minutes to do recap and takeaways. And then if there's questions, hopefully I got the answers. Chris, as we mentioned before, if you want to stop me at any time, anything you want me to precise, please do so. I'll be more than happy to take a second to answer your question. So let's get to the core of it. STC, IIC ratings and measurements. So how does that work? So they're divided in two sections, airborne and impact. Airborne noises basically is anything that travels through the air. So anything like the television, alarm clock, radio, pets, or anything that is not physically in contact with the structure would be considered an airborne sound or airborne basically related sound. It is tested in dB. Ironically enough, when you see an actual rating, the unit of measurement you'll see is an STC, and the STC stands for sound transmission class. So ultimately, it's a number. We'll talk about that in a minute. So the sound transmission class is solely related to the airborne sound noises.
Andre, can I just quickly interject?
Please.
Is STC also covering sound that's coming from outside, like traffic?
Absolutely.
Airplanes? Okay.
Absolutely. So anything that is any noise, really, Chris, that's traveling through a structure, wherever it's coming from, if it is ultimately in the air, so it originates in the air, it's an airborne sound. So absolutely. The only thing I'll add to that, Chris, is they're not always treated the same, because obviously it's more environmental acoustics or building acoustics. So for example, if a building needs to be isolated from the outside world, well, the treatment and how we're approaching it is not exactly the same as what we're going to see inside. It's not the same. It's the same concept, but it's not necessarily the same treatment. It's a lot more drastic and such. Okay. Impact, on the other hand, is anything that does travel through the structure. So anything that's physically creating a vibration is considered an impact sound. So footfall, high heels, moving furniture, kids playing with their toys on the floor. So knocking on a door, anything that's physically in contact with the structure is considered an impact sound. Once again, dB is to some extent the unit of measurement, but the rating that we're going to see related to impact is considered to be an IIC. IIC stands for impact insulation class. Well, here's one thing I will mention about this. You'd be amazed how people will confuse the two or not necessarily know what the real issue is or where it's coming from, and they almost put it all in the same kind of in the same basket. Understanding where your issue could come from or what you're more concerned with can go a long ways, because they absolutely do not work the same. The principles aren't the same. They're related, but they're not the same. So ultimately, anytime we assess a situation, you have to understand there's two, they don't work the same, therefore the treatment may not be the same. So to some extent, looking into the fine prints to some extent goes a long ways. Laboratory, basically here, laboratory testing. So the difference, so the way it works, if you look at the left side, you'll see that the STC, there's going to be a source of sound, whether it's the unit above, underneath, left, right. So an airborne sound with a microphone in a particular unit. So let's keep obviously the conversation about the interiors. It's all direction. So one of the difference with the STC and the IIC is the sound can originate from everywhere, meaning you could be transferring the sound from the unit on the left side of you to the right unit, top to bottom, bottom to top. So for example, if you're in an existing building, you're saying, my neighbors are making noises. Well, is the sound coming from underneath? Is it coming from the top? Is it coming from the side? So depending on the situation, we'll understand that the STC is all direction, hallways to a unit, whatever it may be. And it's also related to a wall-to-wall assembly or a floor ceiling assembly. So it's always about the assembly. So we'll touch on that a lot in March 9th, but to some extent, that's one of the biggest mistakes we see is not understanding how the sound actually works and where it's coming from, where it's going, and then what is it going through. So it's always wall-to-wall assemblies or floor ceiling when it comes to the STC. The IIC is only one direction, top to bottom. So ultimately, there's a tapping machine example like you see on the right that will be on top of the assembly, and you have a receiving machine underneath. Tapping machines creates vibration and it's quite loud, and the receiving machine, the microphone underneath, will basically capture whatever is getting through it. And I've just mentioned that one of the biggest thing to understand is what are we actually testing when we're doing that? We're testing an assembly. We're testing everything from the floor covering, if there's one, up to the ceiling assembly. Not an underlay, not a floor, not a layer of gypsum, not a clip. It's basically testing every single component that we're going to find between the tapping machine and the microphone. And that's true with the STC also. So if there's one takeaway right here is a rating is always and should always be related and linked to an assembly, never to a product. And that is in the middle of a lot of issues and misperception in the flooring industry, particularly. Okay. You're going to also see a different term when an ASTC, very quickly on this, is considered an apparent sound transmission or apparent impact insulation class. What's the difference between an ASTC or AIIC and STC and IIC? Is basically one of them is tested in the field, the other one is considered tested in the laboratory. So the building code is recognizing that when you're testing something into an actual building, that chances are you're going to have a little bit more of a not perfect scenario, not perfect environment. So it is taking into consideration flanking paths. So when you are presented with data, make sure that you're comparing apples to apples. Comparing an IIC in the lab to an AIIC in the field is two different worlds completely. Usually what we say, quick rule, not always 100% apply, but ultimately an AIIC, for example, should normally shoot probably anywhere between 2 to 5 points less than an IIC. And the reason that is because if you look at the assembly here, you'll notice that a direct path, so the red line, is kind of like a lab test. It's not taking into account that the noise or vibration will want to travel through the rest of the structure, therefore making it a little bit more loud. Where you see the blue lines, you're seeing a source of a sound. Well, ultimately, it's going to go through the side walls. It's going to go through the junctions and all of that. And ultimately, it may result in the rating being slightly lower. The good news is the building code recognizes that. And that's why I'll show you on the next slide, its requirement has been adjusted to reflect that exact reality. If ever you're wondering what's the link between the ASTC, AIIC, and F for field, it's ultimately the same thing, except the A is now the new updated norm, let's call it that, when tests are performed. So I'm not going to go too much into details on how that actually works, but just remember that an ASTC or AIIC is basically the new testing method than the F was prior. Okay. On the bottom, you'll notice high frequency impact sound ratings, or what's the HIIC. I'm not trying to be complicated or make things more complicated by any stretch, but in some cases, we go as far as analyzing the high and low frequency within an assembly. So some people have even said before that we invent terms. We don't come up with terms, we keep up with them. So ultimately, if you see an HIIC, basically what that means is all of a sudden we're even capable now of analyzing a structure, an assembly, and figuring out where is the human ear going to be the most susceptible to hear what's happening, and is there treatment that we can do that actually going to fix exactly where we need to fix. So what I'm saying is, yes, there's the STC and IIC, same thing with ASTC and AIIC, but we're even able to go even more in depth as far as analyzing where we're more prone to the sound transfer, which frequency may become more problematic, and fix it at the design stage. So just to give you an example a little bit to how much, to some extent, how deep we can go within the science, okay? Building code requirements and recommendations. Chris, can you do me a favor, please? If ever, I'm not going to go into the chats. If ever you see questions coming in that you think I should answer on the spot, don't be afraid of jumping in there.
Yeah, absolutely. I just was going to comment on the previous slide. That
Please.
What you're saying there is, there's always been the value in dealing with this at the design stage. If you want to stop noise transference meaningfully, the designer has to do it. Now, what you're talking about by getting very targeted about how you could do that, you've upped the value even more of dealing with this before the building obviously is built. Without that sort of approach, it always defaults to, construction's so guilty of being reactive as opposed to proactive, and we try to deal with these problems as they crop up. And that's why the person rolls into the flooring showroom and says, have you got an IIC of 1000 yet? I need that. Do you know what I mean?
Absolutely. And so again, the data and what comes with the data, and we'll talk about it in a minute, on looking at what the building code recommends or requires, and then I'll touch on that. But you're 100% correct, Chris.
Yeah.
Speaking of which, the code in Canada, we'll focus on that for a minute. So the STC is required by code, and the number's 50. Earlier, I was referring to they also recognize the ASTC, so it is 47. So basically 3 points less. The recommended minimum STC is 55. In my world, in the Acoustic world, very rarely do we see people trying to be under that or shooting under that. Usually we'll see people trying to shoot within that recommendation, if not higher. Where the issues come from is the IIC. And the reason is simple. The IIC minimum requirement is non-existent. The code does not require any performance on the IIC for multifamily. Therefore, it doesn't require anything for the AIIC, but the recommendation of the building code is still 55. So what happens is, and that's not me saying this, it's what we see day in, day out, is the IIC gets neglected. The challenge, the number two challenge with that is, it is responsible for no less than 80% of every complaint in multifamily, multi-story. So even though the code doesn't require anything, it does not stop Mr. and Mrs. Smith to complain. It doesn't stop them from basically suing each other or complaining to the property management company, condo board and strata, or even to the builder, depending of the process and who's taking possession what. So if I had one piece of advice for the whole thing, I would say to not neglect the IIC. It is actually and should be on top of mind even more than the STC. So what we'd like to see is that the 55 to be a balance between what people are looking for and what they're designing the building to do on the STC and the IIC. So there's a little bit of a balance in there where we're not seeing this, because you can have the best wall-to-wall assembly in the world or floor ceiling assembly. Chances are people are not necessarily every night throwing a party or putting the television too loud, but they will be walking, and they will be walking at any time of the day. So we are seeing a lot more, and the percentage I shared earlier of noise complaints and whatnot, I'd be willing to bet anything that 90% of those complaints are IIC within that same ratio. So once again, food for thoughts into wherever and however you're working on that. To touch on what you said, Chris, to see high numbers, and the flooring industry could not be more guilty of this, and we are quite frankly trying to change the game and have for years, does that mean that all of a sudden, if you have a high number on a product or whatever it may be, an underlay that's claiming a 76 IIC as an example, is it a guarantee of high performance within your building? Absolutely not. Absolutely not. Can these numbers be achieved in my building? I would say, and then I don't want to conclude too fast, but I would say that anytime you see anything over 62, 63, 65, that's pushing it on any of the STC and IIC, there should be a red flag right there. There should be a red flag that it's virtually impossible to achieve unless you have a wicked carpet tile or a 1970 shaggy carpet. So ultimately, the flooring industry, the hard surface flooring industry particularly, there's no way any structure with anything we see in Canada that would shoot much over these ratings in real life. So we obviously have a problem on our hand and we need to fix it. And one of the ways to fix it is understand how it actually works. And ultimately understanding, which is the next point, understanding what your floor ceiling assembly is, what is it capable of, where is it more prone to having issues, what floor covering are you going to be using, is there a ceiling, is there no ceiling? All these components put together allows us to come up with some ideas and basically some suggestions on what the assembly could look like. But what's even more important than that is, what is the rating that should be associated with those assemblies? And I assure you that the IIC 75 and STC 72 is not it. It's creating a lot more headaches than we think. And it's in the middle of all these lawsuits and complaints and people fighting amongst each other. Okay?
I came across a product a few weeks back on a complaint of acoustic based complaint. I don't know, the product was called Miracle Muffler or something, I forget, but it just claimed in its specs, it just said IIC 73 and made no reference to the test that it achieved that rating. It just stated that. It's just completely meaningless. And until no one in the mix understood exactly what was going on or why they were still hearing sounds having specified this product. And so what you're saying is just underlining the fact that, I mean, you've got to look for the IIC, sure, but you also want to know how it was tested to achieve that result.
100%, Chris. I always use this example. It's like, for those of you familiar with golfing, it's like me saying to you, Chris, that last summer, I golfed 74. Maybe you're not going to want to bet with me, golfing with me. But what I'm not telling you is maybe I played 9 holes versus 18 holes. Yeah, so what happens is I'm not lying with the number I got. I'm not telling you how I got it, how many holes I played. So ultimately, we're flooded, absolutely flooded in the flooring industry with that. And people, quite frankly, they don't want us to know. They don't want you to dig up where the 72 comes from, because if you do, you're going to find out quick enough that it was a 10-inch slab with the absolute best floor you could use. And there's going to be a 14-inch suspended ceiling filled with insulation, which in real life you never see. So there's a lot of that going on. There's no doubt about it.
Hey, Andre, this is Kim Anderson in Winnipeg.
Yeah.
Just a quick question. In terms of, I've always find it a little bit easier to talking to architects or specifiers when it comes to the sound. Talking about the ASTM 2179, which is how does it state it? Standard test method for laboratory measurement of the effectiveness of floor coverings in reducing impact sound. So it's impact sound reduction, but the results are decibels. So my floor goes on top of the floor. it gets tested and it reduces the sound impact by 5 decibels, say for sheet vinyl. Say for a click flooring, it could be 22 decibels. Now they all have a sense of a reality because IIC, oh my, it's baffling everybody.
Yeah,
End users.
great point.
Go ahead.
And Kim, I agree. There's one little thing I'd like to add to this. So I think you're referring to the delta. So the delta rating is a good indicator. Here's the catch. My point is to look deeper into this every time. And I'll tell you why I'm saying this. You could, on a application A, you could use, let's call it underlayment XYZ, and with the same floor and the same and a concrete slab, for example, you could achieve a delta of 15. Ironically enough, if you take that exact same floor, that exact same underlay, and you use it into a light wood frame building, the delta might shrink to 3. So the challenge is it still needs to be in perspective to where it got tested, even if it's a delta. Because
this impact sound reduction is based on concrete floors. So
true enough. All I'm saying is sometimes we see what's going on in the concrete, and ultimately people assume that that's what they're going to get on other structures. But I agree with you. The delta is a good indicator for sure. Absolutely.
It's just a test that I find that is a little less baffling.
Yes.
So when someone, just like you say, oh, it's got, like Chris was saying earlier, IIC 73. Well, what does that mean to a layman or even to an architect? I don't know. It's a bigger number. That must be better.
Agreed.
Well, no, how about we use this for an example? I've done this, and they go, oh, now it's attainable and it's reachable, and they can kind of digest a little bit. And but like you say, it's not perfect, but for now, that's kind of what I use.
I think that's great. I think that we're doing that, or at least looking into it differently than what we've been doing for 20 years. The flooring industry, you're bettering the industry. So I raise my hat to you, sir. No doubt about it that we need to change the language and change the way we get, because again, it's too easy to cut corners. It's too easy to look at a number and put that behind us and move forward. And first thing we know is poor Mr. and Mrs. Smith are paying the price because their condo is noisy and they want to get out of here. So I'm with you.
Good.
Andre, quick heads up. You're at 30 minutes.
Yeah, thank you. Basic principles quickly. I want to talk to you about mass, resilience and decoupling, void treatment, sealing and flanking. There's more. It could be more complex than this, but ultimately I am going to go quickly on them because they go a long ways understanding them. So airborne sounds, 3 principles apply: the presence of mass, the presence of insulation, presence of sealing. In this first example on the left side, more mass you have, more density you have, better off you're going to perform on STC. So example, an 8-inch concrete tower on the STC floor ceiling assembly is always going to outperform out of the gate a steel, for example, or a light wood frame building out of the gate. I'm talking about, unless you go to extremes to get treatment. It doesn't change the fact. The reason that is because a concrete 8-inch concrete is not going to allow sound like voices, television, radio to get through it as easier. That's something that's more porous. Next one in the middle would be insulation. Why is it important to have insulation in a light wood frame application? And why is it important to treat the ceiling, the joist system? It's because if there's nothing to stop the vibration, it's going to create a drum effect. So ultimately, it's not going to get slowed down. So if you look at obviously the video in the middle, you'll notice the insulation is slowing down your STC, and therefore you end up in better shape. Number 3 on the right side is sealing, SEA. What does that mean? It means that sound, especially STC, is a sneaky one. It will find the weakest link within your assembly. So for example, I worked with a builder on the island. We've discussed, even the lighting. You're showing me the plans. I said, you might have a lot of putt lights here, my man. Maybe you want to make sure the electrician is doing the acoustical caulking, and keep an eye out for that, because if you have all these holes in the ceiling, the STC, the airborne, is going to find it, and then ultimately you can have the best ceiling and drywall in the world, but if there's holes everywhere. So that's true with vents, openings, even hotels that have big gaps under the doors. All these things can have the best door in the world, but if you have an inch of air underneath, you're going to hear everything that's going on in the hallways. So that's a very important principle too. Obviously, in the flooring industry, I'm not saying you have control over all of them, but it's important to understand them. Impact, by far the most neglected by a stretch. If you look at the left video, what it is vibration, impact transfer is ultimately our worst enemy, because the impact, the IIC will go from one component to another, will travel from one component to another, and will make it to the unit below. So yeah, we're good on STC, we got some mass, but if we don't find ways to decouple the materials from each other, that's why carpet is so good. But if we don't decouple the components from each other, ultimately that's when we end up with an IIC that's quite low versus an STC. So the key to this is, how can we find a way for the vibration to have nowhere to go? So if you're on a concrete, you have one shot at doing it right. So we're better off picking the right technology. For example, in our group, we're not limited to one technology. We're not limited to one product or one product line. We have a multitude because we're playing with decoupling, concrete, light wood frame, steel, mass timber. Ultimately, are we more prone to high frequency or low? So all these things come into play when it comes to time to slow down the impact transfer. Two things you guys are familiar with that work the same way: electricity and basically heat. So for example, thermal. If you don't put your hand on the element on your oven, you're not going to burn yourself. You create a physical contact, you will. So bottom line is, acoustics on the impact works the exact same way. This is also related to flanking. If the vibration's making it to the structure, it's making the whole thing vibrate, and then ultimately it's our worst enemy. So sooner we control that vibration, closer to the source of the impact we control it, ultimately it does not have time to gain speed through the structure. I'll do a quick demo for you on this, so hopefully you'll hear well. You see my beautiful cooking plate there. So music box, nothing special about it. So what I'll do is I'll play it when it's not touching the board, then I'll play it when it is touching the board, and we'll see if you guys can hear the difference. So hopefully it came. I tested it with Lee and Chris before, so it worked. But ultimately, what that displays is, if there's a gap of air, air is not a good conductor for vibration. As soon as you introduce it to hard surface flooring, a hard substrate, I don't care if it's a concrete or gypcrete topping, no matter what that is, density within anything between the floor to the ceiling, drywall, if it's not decoupled, ultimately you're going to end up with a lower IIC. That's how the science works. So it's a matter of picking the right thing at the right place. Structure types. I'll share some data, information, and again, this is coming from 1,000 tests in our database and 20 years of doing this in different structures. So I'll share a few things on each of the structure. And why is there a section on structure? You'd be amazed how much sometimes we see people saying, well, I'm on a concrete structure, so I don't have to worry about the IIC, or I don't have to worry about sound. You'd be amazed to see how many complaints we do see that come from concrete structures or concrete towers versus others. So they're not all to some extent free from complaints or anything like that. So I'll give you some examples on that and what we're looking at. Concrete, obviously mass, we have a lot. Steel, same thing. Light wood frame, not as much. Mass timber, not as much. So as far as flanking, lower risk for sure of the vibrations, the building's heavier. Steel is high risk, it's metal. So a metal structure, a steel structure, we need to pay attention to the principles, including decoupling. Light wood frame, even more true, and mass timber. Okay, so extremely important out of the gate to understand what we're working on. What's the structure going to be? What are we going to be more prone to transfer versus something else? As far as concrete, quickly, large spectrum of efficiency. The IIC without any floor finish, 28 to 36. Of course, to Chris' point earlier, Sometimes we'll see people trying to find an IIC 36 slab in order for their products to look great. But in reality is we'll see slabs that will be 28 naked with nothing on top, or it'll go to 36. So a polished concrete on its own will sound absolutely terrible when it comes to IIC, specifically the high frequency. The high frequency versus low frequency is more problematic on concrete than it is on anything else. So the low frequency, because it's heavy, is not problematic as much. But the high frequency, high heels or hard soles on your shoes or anything like that, like toys, moving furnitures that don't have any felt pads and things like that, is problematic. You'd be amazed to hear an actual tapping machine on it. It goes right through. You still have obviously different thicknesses, framing levels, structural plans, but great for STC. We still need to pay attention to the IIC. This is, again, coming from 20 years of dealing with property management companies, existing buildings, and new construction.
So Andre, that 28 to 36, is that a 6-inch slab or an 8-inch slab or just a general statement?
But again, it's related to all of it, Chris, because depending on the thickness, I've seen 8-inch slabs shooting 28. I've seen 6-inch shooting 32. So
right.
The bottom line is, depending on which one, we don't always know. So the point is, that's why there's a range. Depending on the thickness, ultimately, you're not going to know out of the gate. There's no guarantees that the slab is going to shoot 36, even though it's 10-inch.
Yeah.
So, but the biggest point with that too, Chris, is it's not sufficient on its own. And the biggest issue is the high frequency. That's why the code even came up with the HIIC kind of deal, right? So we can basically know which technology will perform better on what structure. Okay.
Okay. Yeah.
This is the steel structure. Really quickly, 8 to 10 components. Again, 26 to 43 for that 4-inch of concrete. If you look at light wood frame, naked, no floor finish, 26 to 43 to start. Obviously, it's moving forward. It competes against concrete structure, usually very problematic, but it has the potential to outperform concrete buildings. We're doing it day in, day out, and I have tons of examples of that. If we apply the principles in a light wood frame application, we can do crazy, crazy things. But right now, usually what happens is a floor covering, some kind of a pad, or if it's an LVP or LVT with a backing, gypcrete or concrete topping directly over top plywood, joist system, some insulation, resilient channels, 2 layers of drywall. Put things in perspective. AIIC 47 if you're lucky.
So that's an important point to really underline. You're saying there is hope for wood frame in this whole topic.
100%.
That's really positive. I like that. I was in a building just the other week where, we got access to the above suite and the below suite. The below suite was where the complaint and was being generated, obviously. And so I went up to the upstairs suite, and with the owner up there, we dropped a water bottle that was full of water from 2 feet onto the wood frame, onto the, it was actually LVT, vinyl plank. And so I went downstairs after that was done and phoned her and said, okay, do it again. I want to see this test. And we listened. And it sounded like she dropped a bag of potatoes on the floor, like a dead body had fallen on the floor. It was amazing, because there's absolutely no effort put into that 30-year-old building to decouple the sound transference or break down the sound waves. I love hearing that there's actually hope, because it's an important thing.
And not only there's hope, there's ways, and we're currently doing it. There's, like, as a matter of fact, I would say that we're working on a ton of buildings that are light wood frame, and the bar is the same, the expectations is the same, and it has a bad reputation. It shouldn't. We even speak with the at events with the Woodworks group that operates nationwide, and that's ultimately what they're trying to do, is get rid of the bad rep that the wood frame building will have.
Is this without acoustical toppings, like an inch and a half?
That would be basically before the floor finish.
Wow. Okay, great.
Okay. And again, more prone to flanking, more prone to, that's why it's referring to my delta that I said before. I've seen floor systems and whatnot where we're not paying attention that will shoot 47, 49, and you would think you're in good shape, but you're actually not. So it could be a nightmare pretty quick, but there are ways, and I'll show you a few things in a minute, but there are ways to basically make a light wood frame building very efficient, both on STC and IIC. Mass timber, that's the new kid on the block. You're going to start seeing this a lot more. Ironically enough, everything I just said about light wood frame applies. Meaning, if you look at the slab alone, especially if it's exposed ceiling, exposed mass timber, CLT, glue lam, whatever you want to call it, in some cases, it will shoot on the IIC alone with no topping as an example. It could shoot, we've seen 23. So you're starting with a couple strikes. So that means that if you don't have anything in the ceiling, you better do a heck of a good job over top. Good news is there's hope. There are assemblies that are designed to basically like mitigate flanking, mitigate the STC, mitigate the IIC, high and low frequency. So there are ways to do that. But it is something that we're seeing a lot more of. We're currently working on many of them. And sound is by far the #1 concern. No questions asked. And that's a good thing because some people paid the price a few years back when they actually started plowing the trail. So we're going to start seeing a lot more mass timber buildings.
And just a reminder, the National Building Code for advisory, it's not a requirement, it's just a recommendation, is 54 or 55 for IIC.
Yeah.
Yeah.
55. And honestly, mass timber, Chris, it's a heck of a battle to get there with mass timber with exposed ceiling. If you put a ceiling, you're fine. But without a ceiling, with exposed ceiling, so it's all about knowing what the expectations are. So obviously, we're all about mass timber. I love the idea of using wood, but you need to have, and you need to ask these questions, and we need to have these conversations at the beginning, not like later on in the process. And that's something I'll touch on March 9th. So
modern minimalist kind of design approaches don't lend themselves well to acoustical issues.
Correct. We start paying attention, we work together, we're collaborating with the right people, you can do awesome things. And it's better than having to figure out the solutions after the fact when everything's installed. So that there's no doubt. Very quickly, I'm just showing you some potential ideas of what that could look like. Again, I've mentioned concrete slab. You only have one shot at doing it right for the IIC and for the high frequency. So to some extent, there's obviously, it's not as easy as saying, I'm just going to, use a 3 mil foam. It might save the day. That's not how that works. It's using the right thing in the right place. Again, I've touched on that and I have stories, I have examples of real builders that were stuck in the 47 range on the IIC, and overnight we brought them to 60. So by the way, without a topping. So as you can see here, so there are new ways, new technologies available. And that's even more true when the weight is a concern. So Victoria, BC is an example. We do a lot of work there. We work with BC Housing. So there's a lot going on there, but there are new ways to approach sound insulation with the flooring industry and in the construction industry that can bring us and bring the comfort that people are looking for without necessarily having to change everything we've been doing. So there's hope, especially on the light wood frame in the mass timber industry.
Andre, I think you should make the point here. If you're able to up the IIC or the rating by 2 or 3 or 5 points, that is a significant achievement. I mean, the whole IIC rating system operates kind of like the Richter scale, right? I mean, a jump of 1 is a huge difference. Exponential. There you go.
Absolutely. If you're going from 47, I'll give an example, Chris, since you mentioned it, going from a 47 or 50, even like the number of times we see an 8-inch slab with a laminate floor that shoots 50, you'd be amazed. So people think they're in the 60-ish or 70s. It's not even close. So bottom line is, it's fairly easy to go from 45 or 50 to 52, 54, 55 by using the right thing. In some cases, it's not even more expensive. Just a matter of using the right technology that's going to cover you on the curve. So if you don't understand where you're prone to transferring sound, you may control something that's already controlled. So the reason that we do what we do is we're able to look at basically what we're going to be prone to like what's more prone to transfer and where do we actually need to compensate. So, but to your point, if you're already at 58, 59 range, to go to 61 might be 5, 6, 7 times harder than going from 45 to 50. So absolutely, it becomes exponential as you get higher on the scale.
Hey, Andre, Kim Anderson, Winnipeg again. Are these compositions like, each one of these are a different floor to ceiling type composition. Are
Yes.
they listed with underwriters laboratories like ULC? So that you can go to a ULC book and pick, this is my composition, here's my IIC.
I don't know about listed, but we do have, because you understand there may not be logos on it, but those are all assemblies as part of our recipes. So we do have laboratory testing and ULC, ULC basically norms and all that kind of stuff. So the answer is kind of.
Right, okay, yeah, because
the building code does not, the code on the ceiling, ironically, because of fire, will
Right.
put their foot down a lot when it comes to that. When it comes to sound over top, yeah, there's some like the typical topping and 8-inch slab, but the new innovative ones that, for example, you see in front of you, we have all the data you may need, but that doesn't mean they're listed with the OLC as we speak.
okay, there's no place
Okay.
that you can go. There's no
And by the way,
association.
those we do a lot of buildings with. Just
So there's
you
no
know, right in front.
association or place that you can go for a website and say,
Correct.
okay,
Correct.
thank you.
Okay.
Yep.
And this is basically on a mass timber, because I don't want to take 1 minute more. This is mass timber assemblies. Once again, dry elements with a topping. There are ways to do a heck of a good job, avoid complaints, and make sure that the building has the reputation it requires or it needs to have. So again, this is a small sample of some of the ideas of some assemblies that are available in the market. Same thing with steel structures. Again, you'd be surprised how much steel structure is prone to flanking. So we need to control flanking out of the gate. Okay, so there's systems, excuse me, in the ceiling and under the floor, insulation. I just spoke to a builder in Victoria a couple of days ago where I've made some recommendation on a Hambro system on what they could be doing for their commercial kitchen. They reached out and they talked to us about it. So I made some recommendation, understanding what they were trying to do. Okay. And I know we're basically pretty much there, Chris. So recap and takeaways, requirements versus expectations. I don't mean to preach, but the one thing I will say is this. Mr. and Mrs. Smith do not know what the code asks for, nor do they care in 2022. So what should we offer them? Should a builder offer them a little bit more value on that? I can tell you, we work as a group with developers that are literally making acoustic their #1 selling feature into their condos. That's what they're talking about first and foremost, before anything else. That's where it's going, at least for the people that see the value in doing that. So that doesn't mean you have to be out of pocket. That means that ultimately people are willing to pay for peace of mind. There's no doubt about that. And we're seeing it day in, day out. Acoustics requires specific attention. The ratings equal an assembly. Understand the principles and try to apply them as much as you can. Obviously, we're there to assist you should you need. Know your structure. It's dealing with a concrete is not the same as a lightwood frame steel or mass timber. What's your target? What are you shooting for? Therefore, you can find what your proper assembly is and what your options are. And better acoustics equals less frustration. I could tell you stories all day long about stratas and people that are, it's a nightmare for them. And you know, to some extent, we've decided as a group to change that, on that front and try to at least contribute to people having a little bit more peace of mind. And before we go to question quick, because I'll finish with this, if ever you are working on something, you have questions, or if you're, I know you'd like our guidance, or you go back to the first slide, obviously would be happy. You know, I got my whole team, Gordon Strachan from Vancouver, Christian Wallace, Ontario, and parts of the US. And I got my whole Eastern team too, Simon and Sebastian, Vincent, they're out East that can help out. Any questions?
Tremendous. There's a couple of written questions here. One is by Dawnita. Where did that question go? Hang on. She asks, so are you saying that there is no standard for the test results to be tested? So if
Are you talking about do you know, are we talking about the no standards for the IIC?
That's correct, yes.
Okay.
No, there's not. There's no requirement in the Canadian Building Code whatsoever. There's only a recommendation. So by law, you are not entitled, you're not forced, or it is not mandatory to do anything on the IIC.
Andre, I'm going to put a question on top of that one. When a product, Miracle Muffler, claims a 73 IIC, what do we want to see that company also state? That
how the 72 was achieved with
Right.
what?
And so we would look for an ASTM test standard,
Correct.
like
The
a
one-
four, maybe just chat about that a little bit.
Well, ultimately, there's a lot of numbers there, Chris. So I don't know if I can go back. If you bear with me 1 second here, let me try to go back up top. I'll give them to you.
Mostly we only see a couple, like there's ASTM E90, there's ASTM E490.
E90, you see them here? E92,
Oh, there you go.
E90, that's laboratory testing as an example.
And just so everyone knows that these tests are not likely to reflect what you have on site in your multi-family dwelling. So don't assume that they do.
Well, not only that, it doesn't mean because somebody's using the right ASTM testing method that they're not controlling the environment. You know what I mean? The question isn't necessarily that the test is not ASTM standard or standardized. The question is, if I could test something for fire using the ASTM fire norm, but if I decide to put ceramic tile over top instead of carpet, because I want to test a carpet pad of mine, I've seen it. I have seen someone test a carpet pad, and instead of carpet over top, it was a ceramic tile. So
Yeah,
the test and the norm is the same, but you're controlling the environment. Why are you doing that? People do that in order for the number to be higher, in order to sell more products. That's the only reason people actually do this. So that's why we need to look into the fine prints of ultimately, yes, the standard, but also what was my assembly, because you can change one component within your assembly and it will drastically change the outcome of the result.
And I think all they have to do is just list it as modified. Name the ASTM and then say modified. Don't tell you how. And then people just look at the numbers and say, oh, you've made it.
Yeah, and that's where the misguiding information comes from, Kim. You're right.
Yeah.
Next question. Can you measure an STC rating for hard surfaces?
You can as part of an assembly. So the floor ceiling ASTC, for example, STC, we just did one in Victoria literally 2 weeks ago. So there's a big speaker that shoots sound all around, and there's a microphone in the unit below, but in this case, it was an LVP over top one of our system in a lightwood frame application. So you absolutely can, but if you show data with it, because it's obviously the floor ceiling, you have to show what the full assembly was. And not only that you tested a floor for STC, because you cannot do an STC on a floor. You have to do it on everything between the two units.
Very good. This one is from Rod Norman. Is there a process for on-site testing through Acoustics in the state of Washington?
Currently, there isn't, but if that person wants to reach out, we have a full network of independent acoustic engineers we work with. So if we don't have any contact over there, we may point them in the right direction. So if it's a physical test, as of today, we do have the equipment. We do offer that service. In some cases, that's not necessarily what we do day in, day out. We analyze and whatnot. But in the state of Washington, I could see, I got contacts, example, RWDI, do they have a location? Do they travel there? That's an example I'm giving you.
Okay, Jay Aldridge asks, so if the 73 is the 73 number impossible to get on these flooring pads or the underlays that are offered out there? Is it really just smoke and mirrors?
It is. Well, it is. Let's be a second. Is it possible that I golf 74? It is on 9 holes. So the point is it possible to get 72? Absolutely, but you have to control and to pick all of the components within an assembly that ultimately is going to shoot 72, and that's what these companies usually do. So I'm not saying they're lying to say 72. What we are claiming, Chris, I think you're on board, what we are saying is this assembly is this the same that you have in your building? And 99.9% of the time, you're not going to see the exact same floor with that underlay on a 10-inch slab with a suspended ceiling filled with insulation and 2 or 3 or 4 layers of drywall. So it is smoke and mirrors 99% of the time, because you're never going to see that assembly in real life. But is it possible to shoot that number? Yeah, if you control everything, you build up your floor, it's possible, but we're not going to see it in real life.
So it's a good question here. Warranties, and who's guaranteeing I'm going to get a quiet building when I pull the trigger and pay my money for my new home? It reads, with the many materials and components used to design and build an adequate sound control system, who supplies warranties and guarantees of performance, especially of and for the finished floor system? That comes from S. Johnson.
That's a phenomenal question. We do a lot of presentation with Acoustic Condo, which targets literally the retrofit industry, like the existing buildings. Unfortunately, the challenge with acoustics is there's no guarantees. What I mean by that is you cannot guarantee a performance for the simple fact that there's so many different components within an assembly that ultimately you cannot for sure say you're going to shoot whatever. Even if you look at the ULC for wall-to-wall or floor ceiling, usually what you get in real life is nowhere near, or at least it's not in line with what you're going to see tested in a laboratory. So the second part of that answer is this. On the other hand, to look at all the fine prints, sit down with the right people to look at all the components and determine with data, with the knowledge, with the expertise, we are capable of giving a little bit of a range of what the building will provide for performance. So for example, I can't speak for anybody else, but I can speak for us. If I'm talking to a builder, I know all the components, I'll give you a range where I feel that the building is going to shoot on ASTC and AIIC. If you look at our recipe books, it's going to be a range. We usually end up within that range. That said, there's no guarantees, because I've seen people short-circuiting, for example, the resilient channel in the ceiling where the screws are going all the way through. So there's the installation comes in, obviously quite important, and a choice of all the components. So let's say this. We do everything in our power, and we should put everything in our power and do everything in our power to control the outcome as much as we can and not leave it up to chance, with understanding there may not be a guarantee. So unfortunately, there's no such thing unless I'm not aware of somebody that offers guarantees. Even acoustic engineers, they will write a letter. They could write a letter saying, I've looked at your assemblies and I feel very confident you're going to be within that range. Usually that's suffice. And that's usually obviously with a couple stars in the bottom saying that's if everything goes well and whatnot.
That's by far the most responsible way of doing it, is by range. Yeah.
I agree. And you, again, if you do spend the time on looking at all of this with the right people, your chances of success are drastically higher than necessarily, not paying attention to it or assuming that the number that you're presented to is the right one. No doubt about it.
Tremendous. Good stuff, Andre. We've come full circle, back up at the top of the hour. So we think we're going to wrap things up and